is our first.
Oh, nice.
That means L cannot win.
Why is this not?
I could just see the U, and I thought that was a U.
This is like not.
Saw the AU was 2 down.
I thought
You
Here
only
we
knew
go.
it was Copper that was gone.
I didn't know it was
You
copper.
said
Yeah, he said I'm missing
I'm missing Copper.
Yeah, I know.
It used to be
I
higher.
thought it was
Don't
copper.
blame that on me.
I swear, that's why.
That's not my fault.
No, it was
This is
correct.
not.
What'd you do?
Like a week ago.
I'm
You got tired of your team. You stabbed it. I thought that was like AU.
What happened?
So now we copper instead of.
blaming me for his bad quiz grade.
It's not a bad close game. It's just that this one.
Where's all my markers? My smart markers. Here they are. I don't want dumb markers. I know that.
Green. I want green.
Ooh, I can do some new stuff. It looks like
You should green and red.
green.
Green. Yeah, green.
Well, I can only do one color.
No, green and red.
You got 2 markers?
Yeah, but I'm only gonna write one. Let's see how this looks. Oh, that's not thick enough. Here, let's erase that.
Red.
We need to get a little bit thicker line. How does this look? Can you guys see that? That's hard to see on the. It's hard to see on the video though. We got to do something a little bit brighter. Wow, Ronan, that's recorded.
Let's do red.
Red because it's Christmas colors.
Let's try like a pinkish almost.
Pink.
See how that looks. How's it? Yeah, I like that. All right. So this is bonding basics today. So today we're going to get into real chemistry finally. Finally, real chemistry. So first, let's redefine what is a compound. Let's redefine what is a compound. Anybody remember that definition from previous times?
This is the elements put together that make an equation.
Elements put together. I like to say two or more elements. And what do I have to do to these elements to make them into a compound?
They have to be.
2 or more elements. How are they? Yes, chemically combined. 2 or more elements chemically combined. 2 or more elements chemically combined is how you define a compound. There's 2 main types of compounds. The first type is called a binary compound. Prefix bi means 2. So this is only 2 elements. And this is going to be what we're starting out with today. Only 2 elements. So before you leave today, you're going to be able to name and write formulas for binary compounds. The second type is called polyatomic. Polyatomic. So polyatomic is 3 or more. 3 or more elements. So polyatomic is 3 or more elements. So those are the 2 main types of compounds. So I'm going to make a little sketch of the periodic table. This is one of my better drawings. Wait, I can do better. Boom, boom. Oh yeah, there it is. You guys see that? Does that look?
Well, you need AG. You got AG.
I forgot what?
Hydrogen.
No, I've got it. It's right there. Hold on, I just need to fix the other side.
It just needs to be thinner.
There we go. So make a little sketch on yours of the periodic table. Bottom's not important for this. We're going to split this up into a couple areas. So here's an area. Here's the steps. So there's basically 4 areas on the periodic table. So the first area I'm going to gray out this area over here. Why am I graying out that last column or group on the right?
Gases.
Those are the noble gases, right? And what do the noble gases not do?
Mixed together.
They don't bond, right? They don't bond, they don't make compounds because they already have what?
Full shell.
A full outer shell. They already have a full outer shell. So those are not bonding. There's 3 other areas. Group 1, we're going to call that group 1, group 2, and group 3. So you can label those on your rough sketch of your periodic table. We're going to talk about the types of compounds. So if I match a 1 with a 3, if I match something with a 1, and everything in group 1 is a what? A metal, right? Everything in group 3 is a non-metal, right? Non-metal. If I put a 1 and a 3 together, this is what I like to call regular. So put that kind of in quotations because that's my word, okay? These are regular ionic compounds. Regular ionic compounds. I want to talk about what ionic means in a second. I can also put something from a group 2 with a group 3. Everything in group 2 is a...
Irregular?
Everything in group 2 is what? Transition metal, right? So now I have a transition metal with a non-metal. So these are transition binary compounds, transition binaries. And I can also match a group 3 with itself. I can also match a 3 with a 3. And those are 2 non-metals together. These are called molecular. These are called molecular/covalent compounds. Molecular or covalent compounds. So we can do a 1 and a 3, which is a regular binary ionic compound, a 2 and a 3, which is a transition binary, or a 3 and a 3, which is 2 nonmetals, which is called a molecular. So those are the 3 types of compounds. What?
What's the second one?
Covalent. C-O-V-A-L-E-N-T.
Why not a 1 and a 2?
Because 2 positives do not mix in chemistry. 2 negatives can, but 2 positives don't. Are you caught up? Are you ready to actually make a compound? Okay. We're going to do it. We're going to do it. So, if I was going to actually make a compound, here is what it would look like. So, here is sodium. Sodium has how many valence electrons?
1.
1. So if I did a Lewis dot structure, it would have 1 dot. Agreed?
Yes.
Okay. Chlorine has how many valence electrons? 7. So how many dots would it get? 1, 2, 3, 4, 5, 6, 7. So sodium wants to do what really badly with this 1 electron? Wants to lose it, right? And chlorine wants to do what really badly with 1 electron? Do you see how this could be a perfect match? All right? Matter bonds, right, to become more stable. We have 2 extremely unstable things here. We have sodium metal. If I drop sodium in water, boom, it explodes. I have chlorine gas. If you breathe it in, it kills you. All right? It's a poisonous gas. But if sodium gives or transfers this electron to chlorine, and we show the transfer with an arrow. If sodium gives that electron to chlorine, sodium now has a full outer shell, right? Chlorine now has a full shell as well, yes? And now we have what we put on our French fries. This is table salt. All right, when they bond together, you just made sodium chloride. So the formula for this would just be NaCl. All right, it's just 1 sodium and 1 chlorine. What if it's not a perfect match? What if I have lithium? How many dots does lithium have? 1 valence electron, so 1 dot. And oxygen. Oxygen would have how many dots? 6. So 1, 2, 3, 4, 5, 6. Lithium really badly wants to do what with 1 electron? Lose it. So lithium is going to give that electron to oxygen. And we show the transfer with an arrow. Is lithium happy?
No.
Yeah, it is. It lost 1 electron, yes? Is oxygen happy? No, I just poked the bear. Okay? Because oxygen was 2 electrons away, yes? From having a full outer shell. Now it's how many away? It's only 1. So we've actually made oxygen more reactive at this point, not what we're looking for. So oxygen still wants to gain 1 more electron. Agreed? Does lithium have another one to give? No. So guess what I'm going to need? Another lithium. If I have another lithium, it could give that electron to oxygen. Now is everybody happy? Yes. So the formula for this compound would be Li2O. Li2O, lithium oxide. And we
have to be, so does it have to be even then? Can we write it uneven and it just be really reactive?
no, because that would we're talking about we're making compounds now. If we're bonding, they're going to be even. All right? So what this is basically saying, lithium has what charge? It has a plus 1, right? You guys have that do you have your periodic table out?
Oh,
Right? Lithium has a plus 1 charge. Oxygen has a 2- charge. Agreed? So 2 times positive 1 is positive 2 times positive 1 is positive 2. There's only 1 oxygen here, right? 1 times negative 2 is negative 2. Positive 2 plus negative 2 is 0. So all we're doing is mostly just balancing out the charges, all right, to make them be 0 in a compound. All right, let's go to the hardest one you'd ever have to do. Let's try aluminum and sulfur. Aluminum has 3 dots. Sulfur would have how many? 6. Try this one on your own. Aluminum and sulfur. Try it on your own. Aluminum and sulfur. Anyone think they got it? 2 people. Okay. 3 people think they have it. Come see what people got. You gotta get these notes. Question. I think you got it. Okay. Okay, we got stuff all over the place. Aluminum is going to, it wants to give away 3. Yes? Aluminum gives 1 to sulfur. Aluminum gives 2 to sulfur. Is sulfur happy? Yes. What did we just do to aluminum, though? We poked the bear, right? Because aluminum was 3 electrons away, and now it's only 1. So it still wants to give this electron away, which means I need another sulfur. So here's another sulfur. 1, 2, 3, 4, 5, 6. Aluminum gives that electron away to sulfur. Is aluminum happy? Yeah. What have I now done to sulfur? Poke the bear. So now I need another aluminum. And you think this is going to be a never-ending cycle, but it's not, because aluminum gives that electron to sulfur. Is that sulfur happy? How many electrons can sulfur accept? 2. How many does aluminum have left to give? 2. So I need 1 more sulfur. So here's 1 more sulfur. 1, 2, 3, 4, 5, 6. Give 1. Give 1. Is everybody satisfied?
Aluminum 3, sulfur 3?
It would be aluminum, how many?
2. Yeah.
Al2. Al2S3. So that is the long way, okay? That's the long way of doing these. There's a shortcut. All right, there's a shortcut. But you have to understand what's going on with the electrons before I can show you the shortcut. Are you good with that part? All right, so here we go. Next page. So this is what I like to call the shortcut. This is the shortcut to ionic bonding. So let's talk about what we've talked. This is just going to be a summary of what we talked about so far. Number one, this happens by transfer of electrons. This happens by transfer of electrons. And how are we showing that transfer? How are we showing that transfer on our pictures? With an arrow. Number two, this is between a metal and a nonmetal. A metal and a nonmetal. Number three, the cation. All right, have we talked about a cation yet? I don't think we have. A cation is the positive charge. Guess how I remember the cation is the positive charge? The T looks like a plus. The cation is the positive charge. The cation is the positive charge, which is always going to be the metal, which is going to be first in a compound. So the cation always comes first in a compound, has the positive charge, and that's going to be your metal. The anion, A-N-I-O-N, that does not say onion, even though onions make you cry, which is a negative reaction. All right? Anion is, I like to remember this as a negative ion. That's how I remember anion. The anion has a negative charge, which is going to be the nonmetal. And the anion always comes second. The anion always comes second in a compound. So, cation is positive, anion's negative. That's the basics. Are you guys okay with that so far? So far today we've learned two new things. Cation is positive, anion is negative. So here's the steps. To writing a formula. Here's the steps for formulas. Step one is write cation symbol. So we're looking at the symbol with the charge. Write the cation symbol with the charge. That's step one. Step two is write the anion symbol. Write the anion symbol with the charge. And then step three is the last step. This is super easy. If not a perfect match. So a perfect match would be if it's a 1 plus and a 1 minus, or a 2 plus and a 2 minus, or a 3 plus and a 3 minus, okay? If it's not a perfect match, comma, crisscross. If it's not a perfect match, crisscross. That's it. This is the shortcut. It's super, super, super easy. So that's the steps. Are you ready to try it? We're going to do it. All right? Super easy. Can I go to the next page? You guys caught up? You have crisscross written down? Yes. Okay. So here we go. So you could see something like this. Let's do magnesium. All right. Magnesium oxide. Magnesium oxide. So you would see that, and I would say, what's the formula for magnesium oxide? Look at your steps. Step one is write the cation symbol, right? What is the symbol for magnesium? Mg. What's the charge? We have to write the charge too. Plus 2. So I have Mg plus 2. What is the symbol for oxygen? O. What's the charge? Minus 2.
Why is oxygen oxide?
Oxide is just oxygen. All right, it's what it sounds like. I'll show you why in a second. Okay? So whatever it sounds like, it's that element. Okay? Is this a perfect match? Yeah, it's a 2 and a 2. So the formula is literally just MgO. If it matches, the numbers cancel out because it's just MgO. That means that magnesium has how many to give? 2. Oxygen is how many to take? 2. Perfect match. What if it's not, though? What if we had something like beryllium nitride? Beryllium nitride. Beryllium is what symbol? Be. What is the charge for beryllium? Plus 2. What is the symbol for nitrogen? N. What is the charge on nitrogen? Minus 3. Is that a perfect match? No. So what do we have to do? What does the note say to do? Crisscross. This is all you do. If the charges don't match, are you ready for this? You bring the 2 down to nitrogen and the 3 down to beryllium. And this becomes Be3N2. You just bring the charges down. That's it. It works every single time. You don't bring the charge down with it, you just bring the number down. You just crisscross. That's all. All right, it's kind of cool. Let's do one more. Lithium oxide. We did this one, all right? We did this one with our Lewis dots, right? Lithium is a what charge? Plus 1. Oxygen is a 2. 2 minus. Is that a perfect match? No. So what do I have to do? Crisscross. 2 comes down to lithium. 1 comes down to oxygen. And that becomes what? Li2O. We don't show the 1s because that's a ghost 1. Pretty simple, right? Okay, so that is formulas. Names are even easier. So for the names, there's 2 steps. Step 1 is write the first name. Step 2 is write last name with IDE ending. So you literally keep the first name the same and you change the last name ending to IDE. So possible last names we could have, let's just make a list, would be nitride, oxide, fluoride, there's not a lot, selenide, bromide, what else? Chloride, sulfide, phosphide, and iodide. I think that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there 9 up here? 1, 2, 3, 4, 5, 6, 7. Yep, that's all the possible last names. You don't have to. I just wrote them out there so you can see them. So if I was like, what is the name of this compound? And I wrote MgF2. What's the first name? Magnesium. What's the last name? Yeah, that is magnesium. What? No, the bell's about to ring.
What about magnesium?
There's no magnesiumide because that's always the first name, right?
Oh, because you can only do the negative.
Right. So magnesium fluoride. Or if I had something like this, I don't know, CaCl2. CaCl2. That would be calcium. What? Calcium, Cl2 would be? Chloride. Calcium chloride. Calcium chloride. So, that's the intro.